Good day, everyone. Today, we're diving into an essential concept in machine learning: model evaluation. Imagine you've spent hours building a machine learning model. How can you be sure it actually works the way you expect? That's where evaluation comes in. Model evaluation assesses how well a trained model performs on new, unseen data. It's like testing a student. How well they perform on a test shows how much they've truly understood, not just memorized. When we train a model, it learns patterns from the data we provide, called training data. However, performing well on this training data doesn't guarantee it will work in real-world scenarios. To simulate real-world performance, we evaluate the model using data it hasn't seen before, called the test dataset. This step measures how well the model generalizes, how effectively it applies its knowledge to solve new problems. Let's think about why this is so important. Imagine you've built a model to predict bus schedules for a city's transportation system. During training, it performs perfectly on your dataset, predicting all schedules without errors. But once deployed, it starts making mistakes. Why? Because instead of learning the underlying patterns in the data, it memorized the specific examples from training. This issue, called overfitting, is common in machine learning. Model evaluation helps catch and address this problem by revealing how the model performs on unseen data. Now let's discuss the process step by step. First, we split our dataset into two parts: training data and test data. The training data is used to teach the model, while the test data is kept separate and used only for evaluation. By withholding the test data during training, we can accurately assess how well the model performs when exposed to new examples. This separation is critical to ensure the model isn't just memorizing the training data but is actually learning patterns that can generalize. Once the model is trained, we test it on the unseen test data and compare its predictions to the actual outcomes. This comparison helps us calculate key metrics that tell us how well the model is performing. For example, prediction accuracy measures the percentage of correct predictions. If your model correctly predicts 8 out of 10 shifts, its accuracy is 80%. Another useful metric is the error rate, which shows how often the model gets things wrong. In this case, if the model missed 2 shifts, the error rate would be 20%. These metrics give us valuable insights into the model's strengths and weaknesses. If the accuracy is high and the error rate is low, the model might be ready for deployment. But if the metrics suggest poor performance, it could mean the model needs further refinement, such as adjusting the data or improving its design. Think of model evaluation as a reality check. Without it, you're essentially guessing whether your model will work as intended in real-world situations. Evaluation ensures that your model isn't just optimized for the training data but is also reliable and effective for real-world applications. To sum up, model evaluation is an essential step that bridges the gap between building a model and deploying it with confidence. By splitting data, testing on unseen examples, and analyzing performance metrics, you ensure your model isn't just a good learner but also a trustworthy performer. In the next session, we'll explore specific evaluation metrics in greater detail and learn how to interpret them to improve your models even further. For now, remember, evaluation is the safeguard that turns your machine learning model into a practical, real-world solution.